In this video, we're going to prove that the differential of the inverse of the Sechx function leads you to this expression here. So I've written a three-step method as well as the differential of Sechx of x, just to help you if you wanted to have a go yourself. So to start with, we're going to, the function that we are differentiating, we're going to introduce that as just y. So let y equals the inverse of, sorry, I wrote shine, Sechx of x. We're then going to apply Sechx to both sides of this expression. When you apply it to the left-hand side, you'll be left with just Sechx of y. When you apply it to the right-hand side, it cancels out with the inverse Sechx, leaving you with just x on the right-hand side. We're then going to differentiate both sides with respect to x. You may have realized this is in terms of y, so this will actually end up being in a form of implicit differentiation. Because Sechx differentiates to minus Sechx tant, let's write this out. So we get minus Sechx of y tant of y. But then, like I mentioned, it's implicit differentiation, so we have to multiply dy dx onto it. And that's equal to the differential of x with respect to x, which is just 1. From there, you can get dy dx by dividing both sides by minus Sechx tant y. So we get dy by dx is equal to minus 1 over the Sechx of y multiplied by the tant of y. Now we have to make everything in terms of x. And how we do that is using this identity, which is step number 3. The reason we use this identity is, well, Sechx of y, we can already replace that with x, because that's what we introduced it as. But how do we replace the tant of y in terms of x? That's where this identity comes in useful. We can replace Sechx squared of y with x squared, so we can say 1 minus tant squared of y is equal to x squared. You can then take away 1 from both sides, multiply both sides by minus 1, so you get tant squared y. I don't like the way I rearranged here. Normally I do it the other way. And then you square root both sides, so you get that the tant of y is equal to the square root of 1 minus x squared. So essentially you end up with minus 1 over x times the square root of 1 minus x squared, which is exactly what it's asked you to find in the question. Hopefully that video helped. Be sure to subscribe if it did, and yeah, leave a like as well. Thanks for watching the video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excellineducation.co.uk.